All right, perfect. So for today, we'll be covering some of the 3D design features in EnRoute. So for the structure of the webinar, the teaching segment will be about 30 to 45 minutes, after which we'll have a Q&A for 15 minutes. Today we'll be covering working with reliefs, so the 3D objects in EnRoute. We'll go over some of the 3D surface creation tools, and then at the end we'll be learning how to work with mesh objects in EnRoute. So we'll be covering how to import and apply the Stl files to reliefs in EnRoute. So I guess we'll dive right into it. Today we'll be using the subscription version of EnRoute. I'm currently using build number 6.1.0.19. It may differ from your build a bit. I'm sure most of you will be using build number 6.1.0.15, but as to feature-wise, there's no difference in this build that I'm using. So the 3D applications that we're going to be using today will only be available in the EnRoute Complete version, so the subscription, as well as the EnRoute Pro licenses. So to get started, we'll define our plate. I guess we'll start off with a plate 1 meter by 1 meter, and we'll use a thickness of, let's say, 20 millimeters. So to start working with 3D objects, the most important thing are going to be the reliefs. So let me just draw up some text. We'll make so we'll zoom in a bit and make this a lot bigger. So before I can go start working with this, I will have to convert the text to curves. I'll do that through the draw menu under text curves. And then we will make a few copies of this text. So as you can see, one of the contours is red and the others are blue. This means that all right, I see someone missed a part. Exactly which part would you like me to cover again? We'll be sending a recording of the webinar to everyone who has registered either way. So if you have missed something important, you can always go back over the recording. So to start working with 3D, we'll have to select our contours. The red contour here is going to be considered as a whole. So if you have multiple contours and one is completely enclosed in another one, EnRoute will consider that as a whole. This can be used for masking when creating 3D objects, but also for tool pathing, for example. So to create our relief, we'll have to go to the surface menu. You can do that through here, or you can use the hotkeys here. I'll be working through the surface menu for this presentation. So once you have the surface menu selected, we'll have 3 types of reliefs in EnRoute. So the first one will be a round relief, second the beveled one, and the third one will be a flat relief. Here, under the types of reliefs, we'll have our application methods. So we can add to reliefs, we subtract, merge the highest points, the lowest points, or replace the relief in its entirety. So for this one, I will quickly show you the different types of reliefs. So I will apply the round one to this, the beveled one to this one, and then a flat one to the last. And let's give that a height of 5 millimeters, let's say. And then if we go and have a look in the other views, so I will just render everything. So hitting Shift F9 will render your reliefs. You can also do that through the surface menu. So in here we'll have our round relief, our beveled one here, and the flat one in here. By double clicking on the top here, we can go into the other views in EnRoute. So by right clicking, you can drag around, and holding down the right mouse button, you can drag around the plane in EnRoute. If you hold down the shift button as well, then you can rotate everything. So here we see our round relief, our beveled one, and the flat relief. Going back in here, I'll just remove the reliefs from everything. So we'll just do this here. To continue showing you the application methods and as well as the way of adding the relief. So you can add, and we'll use the round relief for this. So normal, if you use the normal type of application, then your height of your relief would be defined by the angle that you set up here. Well, we can choose a resolution as well, which will define the DPI of the relief. Typically, for most applications, a resolution of 100 will be enough. But if you're working with very small parts, you may have to increase the resolution for accurate tool pathing. So if we apply the angle of 71 to the relief, you will see that the height in here will be a bit higher than before. Let me just leave everything here, and we'll work with this one. And I will make a few copies of this. So for the first one, we will use the normal application, and then maybe make our height higher like this. There you go. So for the next one, we can just select new contours. We don't have to go back into the menu and select the create relief option again. So for this one, we'll use a constant height. We'll make the height, let's say 15. And we'll add a base of 3. Then we can also scale it to this height. We'll use 15 as well, so we can see the difference. And then for the last one, we can limit the height to, let's say, 5. And then we'll remove the base entirely, so like this. And then when we render it again, you can see the difference between them. So here we have the normal one. So this will use the width of the contours and the angle of the relief to define the height. For this one, we had set the constant height. So that would be this one. So you can see the height across the entire relief is the same. For the scale to height, it scales the angles to match the height that you have entered. However, it will still use the width of the contours to define the height as it goes along applying the relief. And the last one here, you can see that it has limited the relief. So once it hits that height of 5, the relief just gets cut off and the rest becomes a flat relief. So here we have the beveled or rounded edge, and then the flat relief as of 5 millimeters. On the base, I will maybe show you with a beveled relief. That may be the easiest thing to do. So if we remove this, select it again, go to the surface menu, choose the beveled relief. We will do the normal application method and we'll choose an angle like this. So now it will use the width of the curves and the angle to define the height. And then we can also enter in a base, which will kind of, it means that it will just go straight up 5 millimeters, and then it will apply the angled relief to it. So if we render this and go into the perspective view, you can see that the base has not been added. So if you're working with reliefs, what I like to do often is just create a flat relief like this. So you just draw a square, you go to the surface menu, choose a flat relief, we remove the base and height. And then if we render it, you can see that there is just one flat squared relief in your design. And starting with this, you can start using contours to modify this relief. So let's say I'll just draw an ellipse. Just one moment. All right, I will put that in the relief that I created. And so whenever you want to modify a relief, you can do so by drawing additional contours. And then before going into the surface menu, you will have to select the relief as well as the contours that you're going to use to modify the relief. So for this one, I will render it, create relief. Let's say I want to have a round relief, but instead of adding to the relief or merging the highest points of the relief, for this one, I would like to subtract from it. And so now you can see we've created this drop in our relief. And now we could, for example, just go back in there. We'll write some text and make this a bit larger. And then I will remove this curve as we will no longer be needing it to modify this relief. Again, select the relief, the contours, go to the surface menu. And now we'd like to add this EnRoute 3D to the existing relief. And for this one, I'm going to use a beveled relief. And I will put a base in there of 5. So now I forgot to convert the text curves. you will receive an automated warning from EnRoute asking you if you want to convert them. In this case, I would like to do so. And then again, when we render it, we'll now see that we have, I'll just delete the curves that we've used. Now in the perspective view, if we render it, we'll see that we have added our EnRoute to the existing relief, and you can see that it is following the beveled edge that we cut out using the rounded relief and the subtract method. The other methods, application methods here, will quickly show you as well. For that, we'll just draw a contour like this. And I will write some text in there. EnRoute 3D once again. This, scale this up a bit. Like that. I'll make multiple copies so you can see the differences in application methods. So now for the first one, we'll just add a beveled relief. As a matter of fact, I'm going to add a beveled relief to each of them like this. Same for this one. And the other two as well. So now we have 4 of these, and we're going to use the EnRoute contours to modify them further. So for this one, I will do a beveled relief. I will add to the relief. Once I hit apply, I'm going to make this a bit smaller. Once I hit apply, you will notice that EnRoute has been added right on top, following the shape of the relief that was already there. The subtract method will work in a similar way, but then instead of adding, it will just take it out of the shape. So if we then go here, you can also see that it follows the shape of our EnRoute object. If you choose merge highest, then it will actually only merge in there if it will only add to the relief if the points in our relief that we're adding to it are higher. So I will just add a base of, let's say, 50 to this. And then when I hit apply, you'll notice it gets added here on top of it, but it's not following the shape anymore. It's just added on top, and it's only adding the parts on top which are in the relief we just made, would be higher than our existing object anyway. The other way around, so let's do it for the last one. For this one, we will merge the lowest points, and this is basically just the opposite of merging the highest points. So we'll do that as well, and then we can show you what that And I will, one moment, change our relief so that there are lower points. So let's do the base a little lower. And now you'll see the same object as we have here, but it's, instead of being on top of it, inside of it. I'll just use Control-Z to undo that, and then I will just create another relief, and I will use the replace relief application methods, which will replace it entirely. So so now whether it would be higher or lower, where this new relief will be added, the other relief will be removed completely. Of course, when you're working with a canvas like I usually do, I will just make a new one here. I'll create the relief. Just make a flat canvas, no base. And I'll apply that here. We can use other types of already existing reliefs and join them with our relief that we already have. So joining a new relief with our base relief, let's say. I'm just going to apply this here. So a fleur-de-lis, I will increase the size a lot. Then I will go here. I'll create a beveled relief. We'll do a constant height, and I will make that 15, let's say. I want to add to it. So now EnRoute's just calculating how to apply relief. So here we go. We now have these two reliefs that would look like the following. In the perspective view, you can see here. And through the surface menu, we now have the possibility to merge reliefs. So it will ask you here to select our base relief, which will be a canvas. And we'll hit next here. And then we'll have to select our relief or multiple reliefs that we want to merge with the base relief. In this case, we'd want to add to the relief. And once we hit OK, our existing relief will have been added. Well, our fleur-de-lis relief will have been added to our canvas. As you can see, it's only been added where the canvas exists. So if you'd like to combine these reliefs, you could simply select both here, go to the surface menu and hit combine. Which will essentially add it to it, but also the parts that are outside of the canvas that we're using here. What I would like to show you as well, there is a difference if you combine the relief when it's completely inside of the other relief. So if you then go into the surface menu and hit combine reliefs, what it's going to do then is actually cut out the relief from your base relief. So the relief that's completely enclosed inside of the other will be cut out of it completely. Way I find this useful is if I have multiple layers and for example, I design my background on the first layer, and once I'm ready to toolpath this, I will take this fleur-de-lis from one layer, and I would have put controls at this. So this one, you can hit Control C and then go to the layer number 2 and hit Control Shift V, which will copy your object to your active layer. But for example, now if we would want to toolpath our background, which would be this object, we of course don't want to route out anything here because we might want to apply a different strategy of toolpathing to our fleur-de-lis. So what we would then do is simply select both here and combine these reliefs. So whenever we start toolpathing background, we'll be sure that it doesn't toolpath this part here. Continuing on, so now I've shown you kind of the basics of creating reliefs. We have other application or 3D surfacing tools. For that, I will also use a base relief to show you, but you can also apply these as a mesh object. So let me just... here. So for the surfacing tools, maybe the first ones I will show as mesh objects. So then you don't have to create a canvas to create them on. The first one would be the Revolve. I'm just going to draw a quick contour. Let's make a type of bowl for this one. So we're not gonna try and win any awards for design, but just to show you the possibilities and the technique of the Revolve tool. So what I'm going to do with this is I'm going to revolve it around its axis, and then we'll be able to, let me just retrieve this one. All right, so going through the Create Surface menu, we can choose our Revolve feature. Here it will ask us to select our contours that we're going to want to revolve. So we'll do that here. We can select an axis of revolution, but we're not going to do that in this case. We'll have our start and end angle. So I'm going to revolve this 360 degrees. And for this one, I'm going to create a mesh object. So our slices here will be how many parts we make going across. So as I'm going to revolve it 360 degrees, I'm going to choose to make 360 slices. And our stacks will define the accuracy of our objects. I'm going to go for 50 there. And if I then hit OK and render this, you can see we've created a type of bowl. We would have to rotate this if we're going to if we're going to route this. We will have to apply this to a relief because EnRoute's not able to add toolpaths to a mesh directly. So then we can go to the rotate menu, choose to rotate along the x-axis, and let's do that at 90 degrees. Which will put it way up there. So going through here, we can also just select it. Maybe I'll scale it down a little bit. So the tool I'm using here is the Precision Input Center. For scaling, rotating, and moving objects, this would be the go-to tool. You can go to it through the View menu or just by hitting F2. And then for moving it down into our plate, we would have to select it there. We want to move the bottom to, let's say, -20. We hit OK. It will move it down into our plate. But in this case, if we want to apply it to a relief, I would actually put it on 0 because contours that we draw are always created on top of the plate. And let's say if we want to then actually route this, maybe I will make it a little bit smaller. Thinner so that it fits into our plate. And then we can actually use the canvas here and move that over there. We might make this a little bit smaller. And then we can go to our surface menu and choose to apply the mesh to our relief. So we want to add it to our relief. Hit apply here. And then once we've done that, we have a relief, our mesh has been applied, and we would be able to toolpath this. So going through our next surface tool, we have the spin tool. For this one, I will just draw a curve like this. And the spin tool we're going to use to spin this around and create a 3D object as well. So the spin tool can be used just by going into the surface menu, choosing spin. We'll move this to where we want to spin it around. We'll choose or select the contour to spin around here. Choose our start angle and our end angle. You can also choose that by simply drawing it. Here I'm going to produce a mesh as well. You also have the possibility, or for this one, I will just first draw a relief, and then I'm going to add this spin to the relief. So going to the surface menu, we can create a flat relief here. And then we are going to select the relief, create our surface, select the spin tool, select the contour, choose to add to our relief. We'll just use the start angle of 0 and the angle of 360, and then we'll hit OK. And what you can see now is it has taken this contour and it has spun it around across the relief, creating this shape. There are, however, more options in this case. Let's just undo this. For this tool, you have the ability to create more variation in it using a height control curve and a width control curve. So for that, I will just start by drawing this curve first. Let me just draw a line here like this. We use our point editing tools. Make it go up a little, then I will use our multi-copy tool to create 12 copies. I will align these start and end points. Let's make 12 of them like this. And I will close this. I will select every other tool, every other curve here. And then I will use the precision input center to rotate this along the x-axis by 180 degrees. Little mistake there. So I would want to rotate them from the bottom. So like this. What I'll do then is I will merge these together through the transform menu. So now this would be our width control curve, and we'll just copy this for a height control curve. And maybe we'll scale them down a little bit. And again, going into our tool, we'll select our relief. So every time you want to modify relief, make sure it is selected. Then we will go to our spin tool again. We'll move that here. We'll select this contour to spin around. We'll choose this as our height control curve. So this will define the height. The more you drag this down, the less variation in height you will get. So I'll choose that like this. And then I'll just go for the width control curve as well. Like this. And once we've done that, we just hit OK. So now EnRoute has loaded it. We'll go into the perspective view and we will render it. So now EnRoute has made a variance in height, so you can see it disappears as it goes along and then comes back up here. And the width also going from the circle out and then coming back in, which is controlled by the width curve. So for creating ornaments on wood, this would be a very useful tool. For the next tool, we can use, that will be the Extrusion Tool. I will just draw a path for the Extrusion Tool to follow, and then I will just draw up a contour that we can extrude. One moment, so seem to be having some issues here. Let me just close all the files and start a new one. So I'll keep using the same size file. We'll again draw our contour to follow for our extrusion tool, and then we'll also draw the contour that we're going to want to extrude. So I'll just draw an uneven contour so you can see which side will be extruded where. Going into the surface menu, create surface and choose our extrude tool. Here the wizard will show you to select the contours that you'd like to extrude and the path that should be followed. Because we have no existing relief, I'm just going to choose to produce a mesh. And then the stacks will be the sections along the path to follow. So let me just create 300. And what we've created now is this tool. So you can see on the outside, we have this part of the contour, extrusion, and on the inside, we'll have the left part. As you can see here, the corners are not squared. We can, however, make them so if we choose the miter option. So I'll just make a new plate again. Maybe I'll make my to be extruded contour a little bit different. Moment, so we'll just go up straight here. Like this. And then we can go back into the surface tool, choose our extrusion again, choose the contours that will have to be extruded, path to follow, and then check our miter option. And then you can see that it has squared corners. And we've made this extrusion, which can be used, for example, to go around your design. The extrusion tool also allows for adding revolutions as you go through the extrusion. I'll just show this with an ellipse or a circle. Let's do like that. And then we just move the circle a little more into play. And then we'll offset this by 16. We can use this one to create a flat relief, so normal flat relief. And then use our point editing tools to modify this contour to be extruded. Then we're going to modify this relief, so we're going to select it first. Then we'll go to surface, create surface, choose extrusion. We'll select our contour and our path to follow. We're going to add to the relief, and we're going to add a rotation. So we'll rotate, let's say 4 times as we go along the contour. Which will make us end up with this knot going around our base design. And then, for example, we can use some other contours to modify the middle of it, creating our sign. The last 3D surface tool that I'm going to show you will be the sweep along 2 rails. I will modify an existing relief for this one as well. Then I will have to draw the rails that I will be using. And I will use these rails to sweep certain cross sections over. So I will use these contours to sweep over the rails, creating our shape. Let me just make that one again. Like this. And you can select multiple ones on the same sweep section multiple times. So it will become a bit more clear in a second. So I'm going to modify this relief. So I will select it, choose sweep 2 rails. I'm going to select this rail and then the second one. Of course, the rails have to point toward the same direction or you will end up with a very strange looking relief. So I'm going to select the first sweep section. It will put that on the left-hand side. Then I'm going to select the one I want in the middle, which will be added here. And if I then select this one again, then the right one will move toward the middle. And this one will be added here. So you're sliding them onto the rails, in this case, from the right-hand side. And then you can move these around across the rails as well. So here again, I'm going to choose to add to a relief. I will not use a predefined height or base. And once I hit OK, as you can see where the sections start, we have created our relief. And from the perspective view, it would look like this. So we can then use this as a canvas to make the rest of our design. Of course, to use this on the plate that we'd be using now, we would have to scale it down. So coming through to the last part of the webinar, which would be importing and using mesh objects. So through the import filter in EnRoute, we have the possibility, let's see here, to import STL files. In this case, what I will be importing is going to be this one first, just to show you how something is imported into EnRoute. So whenever we import an STL, it comes into EnRoute in the shape that we've designed it. So if we would import this one, we would have to start by moving it down onto the plate and rotating it first. So we could go about that by simply rotating it here along the y-axis by 90 degrees. And then we can move it. We can move it on top of the plate. So the bottom we want at 0. And through our solutions menu, we would have the possibility to draw a block around this. So we'll create an offset of 10, F10, like this. So we'll select our object first, and we'll put the block around it. Like this. We'll use this block to create a flat relief. And what we'll do then is select both of them, and then we'll go to the surface menu, and we will choose to apply this mesh and add it to our relief. Once that is done, we can actually delete this one. We'll have to note the thickness of this. So this is 6.0933, because as you can see, there is no hole in here, and we still have the block around our object. So what we would want to do, let me just delete this file first. Go to our surface menu, and we'll want to extract a slice from this as well. So the slice thickness, we'll choose 6.0933, and we'll choose to produce a mask and separate our slice onto a new layer. And then going through slice 1 here, you can see that we've sliced off the bottom part. And the reason I create a mask is because then I can use these contours to apply toolpaths. Let me just ungroup this and delete this one. So I can now use these contours to create the toolpaths, because as you can see, we would only have to route a part of this STL file or a part of this relief as a 3D object. So the flat part we can just route with an end mill in 2D, and just this edge we would need to route in 3D. So what I would do here is I would simply measure this, how much this is, so about 20 mil. Then I'd go back in here and I would offset this by, let's say, 25 millimeter and apply it. Cool. And I can group these together. And if I then align this on top again, let's just move a little bit like this, align it like that. And now if we select both of them and we would choose to toolpath it, of course, first we would want to sink this into our plate. So we go and align our relief to the top of the plate. And then if we select both of these, we could apply our ball nose tool, for example, just to this part. And we see that this is about 6 mil deep. And then you can see only this part would have to be routed in 3D and the rest in 2D, which will speed up the routing part of your job tremendously. There's also a faster way to get a relief from your STL file, which would be our import filter, STL to relief. However, to do so, you would need a relief that's been rotated correctly. So what I would have to do here is open this with 3D Builder, for example. Import this model. And then if we select our object, we can rotate it like that. Like this. And then we would have to move it down onto the plate. And then if we save this, so I'll just discard this one, I would end up with this rotated version. And then if I choose the STL to relief import filter, I'll choose the resolution of 100. Then it would be brought in directly as a relief, which would be a lot faster and you'd be able to avoid many steps going through EnRoute. Of course, here as well, you would have to slice this. So you can just see the thickness here. Go to the surface menu and extract your slice of 6.093. Which would make you end up with the same object as well. So to speed up importing and transforming the STL to a relief, I would simply go to 3D Builder, rotate it as you need it, save it, and then bring it into EnRoute using the 3D to relief filter. So this would conclude all of the topics in our webinar today. If you have any questions, please feel free to ask them. If you get a recording of the webinar and something wasn't clear to you, then of course you can always reach us on our phone number during our office hours, which are 9 to 6 Brussels times, or you can simply send us an email to our support channel, and you can also reach us via our website. So if you'd like to see any topics in a future webinar, of course, you can suggest them here. Toolpathing in 3D, we can cover in a later webinar as well. If you already have any specific questions, you can give us a call or drop us an email, and then we can assist you on any particular job that you're trying to toolpath. You're welcome. If there are any questions, let us know. If you think of something later, as I said, you can always reach us through our support. All right. I'll be ending the session. If you think of anything else, let us know. Everybody have a nice day, good evening, and stay safe.